everyone. I guess we're going to start now. Hi, I'm Emanuele. Yeah, you might know me as a GTK team developer. I've been involved in various stuff in the GNOME community for like about 20 years now. So if you don't know me, then I hope I'll make a good first impression at this point. So today I'm going to talk about Oxidizing GTK, which is a topic that it's probably going to be contentious, so just bear with me for a second. So as usual for my presentations, there's a disclaimer. I started a lot of presentations this way. So a lot of this presentation is based on a thought experiment. I don't want to give a bad impression or false impression that this is sanctioned in any way, shape, or form. These are my personal ideas and thoughts and experiences. The tone of this whole presentation may sound a bit dire in place. Please do not be alarmed. Because while I think that things need to change in the future in the GTK space, and that ultimately there is a time limit to what we can do and what we can achieve, I don't think we are on a clock yet. It's been 25 years. GTK is like 25 years old, more than 25 years old now. We can take some more time to get things right before just plunging ahead. But the presentation, what I'm trying to do is mainly trying to impress a feeling not of urgency, but of possibility. There is work to do, but there is space for experimentation. So, why? As I said, GTK is more than 25 years old, so it's an old project, it's an old toolkit. There's no point dancing around the matter. It encodes roughly 25 years of knowledge on how to write a GUI toolkit for Linux across different display servers and iterations of the graphics subsystem and rendering models. Depending on how you count it, GTK4, which is the latest API version, is between 7 and 3 years old at this point. And while we managed to shed a ton of cruft that we accumulated over the years, some of the internals are still the way they are because they were committed that way. So things like input, text, rendering, and widget layout. Even the windowing system backends are kind of the same as they were in GTK2, GTK3. GTK also implements a complete toolkit for X11, a fairly complete toolkit for Wayland, minus some optional extensions to the protocol, and a somewhat competent toolkit for Windows and macOS. We usually refactor what we can, and we drop broken abstractions and layering violations, and we committed them many times over the years. But the length of each iteration has to be kind of counterbalanced with the ability of application developers to sustain the rate of change. So we spent 9 years with the GTK2 API series, 9 years with the GTK3 API series, and while the GTK4 API series is likely going to be shorter, it's not going to be shorter by a lot. And also, with each and every iteration of the GTK API, so 2, 3, 4, we do need to provide larger and better incentives for porting applications and desktop environments to that new major version. Otherwise, GTK will become a science experiment, and it will be perfect, but will be used by exactly nobody. GObject is kind of slightly newer than GTK. It's 2001-ish, but it's basically, it's more than 20 years old. It was designed for a very different era. And we might think GObject as this newfangled technology, but it's just a GTK type system that came with GTK 1.x, just moved down the stack and with a different namespace, with additional functionality that didn't exist at the time, but the basics are still the same. It's a runtime type system that is modeled on C++ and Java object models. It has multi-dispatch in the form of signals, and it has internal state mutators in the form of properties. That's it. The same reason why GObject allows us to create a complete software development platform is also the reason why touching the type system is incredibly complicated. So the runtime aspect of the type system is problematic. There is no or very little compile time aspect, which means we need to run the code to understand how the type system works or what it does. It's why GObject introspection cannot be cross-compiled without having native toolchains. You basically have to instantiate the types to understand what kind of properties, what kind of signals, and what kind of inheritance they have. If you cannot do that at compile time, you need to run code. And since you have no compile time aspect, the test suite that we have are incredibly complicated. We have an entire test that is not auto-generated, but it uses runtime reflection to see if the GTK objects are initializing the properties that they declare with the right default value. And sometimes that fails. Why? You have to run it to know. So there's another problem with the runtime aspect, which is we have a runtime aspect in C, but how does that mesh with the runtime aspect of using the same API in different languages? Reference counting towards garbage collection, inheritance, who knows? So there are also limitations in the threading model. It's a lot. Sorry. But aside from technological issues, which are many, it's not really about technological issues at all. It's about social issues. And the core of it is we're still using C, which is a language that is type safe only if all your types are integers. And even there, it's actually pretty terrible at defining what those types are. So raise your hand if you know how big an enum is. You're all wrong. Because the C spec doesn't define that. How big is the bool type in C99? Nobody knows. Not even the C, the ISO C working group knows how big it is. It's not even like the undefined behaviors or the implementation defined behaviors. It's just that C developers are very slowly renewable resource. We can write documentation, we can improve the tutorials and mentor newcomers every day of the week and twice on a Sunday. But the inescapable truth is that the world has, by and large, moved on from C. It's great for people like me who have job security, job done. But it's kind of like being a COBOL developer. It's not great. It's also not great for GTK because at some point there is going to be very, very few people left that can affect change on the toolkit and on the platform. And every time we increase the size of the platform, it gets more complicated to do that because there are very, very few people who can do that. And at the end of the day, you might like C just as somebody else might dislike it. And yeah, but at the end of the day, if a project doesn't have new contributors, then we might just pack up and leave. One of the things that happened like pretty constantly during the history of GNOME is that there are cycles in the development of GNOME applications. Once upon a time, all our applications were written in C. Sadly, we still are writing applications in C for some, like, I don't know, brain worms. Then we had Python, then we had Vala, then we had JavaScript, and now it's mostly Rust. And the reason why it happens is in part because of the hype. Like, IT works on hype. But it's also, on the social perspective, is like a network effect. People see new projects being written in a new language or a fairly established language, and that gives them some sort of security blanket. They find a new issue. If they find a new issue, they can like talk to people and like read other code to understand that. And the end result is that more people file issues, then more people submit merge requests, more people write tutorials and documentation, and they get involved in the project. Library development in GNOME has been stuck on C for 25 years. We haven't moved from the original announcement from Miguel that said that we should write our libraries in C and then write application in Guile. That worked out pretty fine. I'm sure we all know our Lisp. But we improved the way we write documentation and tutorials and stuff like that. We made it incredibly easy to fix the documentation, add new stuff there. But you cannot ask people to just jump in with C development, and you cannot ask the people that are already doing like library development to also write a ton of new documentation, new tutorials, because they're already busy doing the software stuff. And they're doing that, the result is like a team 10 times the size, and there is just no time. And while C might allow you to do nasty and scary, clever things, it's like really terrible at every step of the way. 20 years after the creation of the spec, we are starting to use C99 in the GNOME platform. We have designated initializers, we have compound literals, we have declarations after statements, and it's great, except it really is not. The code is not any more like readable or ergonomic. We cannot use, for instance, cleanup attributes because we support, not in GNOME per se, GNOME can do it, but GTK and glib cannot do it because we support the Microsoft Visual C compiler. And the Visual C compiler doesn't have cleanup attributes, which are a GCC and CLang feature. And that complicates our code. That makes it harder to read, harder to follow, and harder to fix if something goes wrong, because things will go wrong. We are all still visited by the curses of developing like in the 90s, well into like the third decade of the 21st century. And high-level languages like have higher order constructs and optimizations that make writing correct code a lot easier and a lot more reliably performant. And yeah, we can be real men, real women, and real furry creatures from Alpha Centauri, but at some point, just not minding the pain isn't going to make the pain go away. And we cannot self-select our community based on pain tolerance. And yes, I am a Linux user of 25 years and a Linux desktop developer of 20, so that might sound a bit rich coming from me, but I mean, the question is there an upper limit to the amount of pain a human being can sustain, or a limit to the amount of pain that human beings can inflict upon others? The existence of the C ISO working group seems to indicate the answer to both questions is negative. The standard body for the C programming language will not save us. It's pointless to try. And if you don't believe me, this is straight from the ISO C working group. It will not happen. So, how would you take a code base that measures in the roughly 500,000 lines of C code and integrate a higher level language into it in order to replace that aging C code. The word you're looking for is carefully. So GTK will not be the first project looking at doing that. And so we can look at other projects that did the jump and see what kind of constraints they're operating under and see what they did that we can copy or at least take inspiration from. So librsvg is probably the most notable project that has been incrementally ported from GObject-C to Rust. It still, unfortunately, uses autotools. So that's -1, Federico. librsvg uses various crates from the Rust ecosystem, which are used to be vendored. Nowadays, I don't think they're vendored anymore in release tarbles. The API surface of librsvg is pretty small. It's basically a handwritten C header file to maintain backward compatibility with other colors and generate the introspection. It's small enough that it doesn't go through any code generation whatsoever. But also it exposes its own API as a Rust crate. So in theory, you can, well, not in theory, you can use it from Rust directly. So it's a mixed API. GStreamer is the other consumer of the GObject type system. As long as you implement GObject, you can write pipeline elements for GStreamer in any language you want. But it seems that at the moment, Rust is the favorite for the next generation of GStreamer elements. They started integrating Rust for specific bits inside the core of GStreamer, but out of 3 elements written in Rust are used in as a separate API, use a separate API. One of the things that GStreamer developers are doing is incrementally fixing Meson, their build system, to be able to integrate Rust crates into the pipeline as Meson subprojects. Serd wrote an interesting blog post about that. Mesa started off as C code base. They introduced C++ because, let's be honest, writing a parser and a compiler for GPU-oriented languages like GLSL and its intermediate representations, it's a lot easier if you can just copy-paste the examples from the Dragon book. Then when they realized that the GLSL compiler that they had was pretty crap, they phased out C++, and now it lives only in specific drivers. But unperturbed by that particular misadventure with C++, the Mesa developers introduced Rust for implementing OpenCL, which is the compute core language. They don't use Cargo. They only use Meson. They worked, one of the Mesa developers, Dylan Baker, worked on improving Meson support for external crates and compiling Rust inside another Meson project. They do code generation to turn C header files into Rust shims, so you can call into the C code base from Rust, and then vice versa. They expose an API, an internal API. The Linux kernel, it's probably the easiest one. They started adding Rust because they too have a problem of C being bad, and the main difference is that the Linux kernel does not have standard library requirements. So they have their own internal standard library. Right now, Rust is used only for drivers, but who knows? In the future, it might happen that they will add more core components when written in Rust. So you might have noticed that all the case studies have a thing in common. They are large C and C++ code bases that integrate Rust. And yeah, so I'm not going to try and sell Rust to you. C developers like me, they kind of like small languages, and a talk from me, a C developer that has been like mucking about with the language and the GNOME community for fun and profit, not much profit, but yeah, for like 20 years. I can only tell you that you can teach an old dog new tricks. And there is a potential of getting more people involved without necessarily teaching them the monster's manual of advanced Dungeons and Dragons as a precondition. So, yes, you might find Rust like a tragic explosion in a glyph factory, but there is no point. We're not going back. The C language is kind of a thing that doesn't exist anymore. Nobody's going to write a very small language that looks like C, it behaves like C, because why would you? So, title drop. As the creator of the pinboard bookmark surfaces and world-renowned Vocaloid, Hatsune Miku said in their famous tweet, programmers put our things off until they become untenable to ignore, and any movement towards change is the result of dramatic underestimation of the effort involved. We've been doing that pretty well for 2 decades in GNOME. So the thesis for this entire presentation is that the window of time is kind of getting smaller. And for any avoidance of doubt, GTK is not a security boundary, at all. You should never, ever run GTK code as root or a privileged user. GTK itself would try really, really hard to discourage you from doing this by just erroring out. But this does not mean that the GTK code should not take into account safety, because if the compiler and the type system can help us while writing code and mock us for our all-too-human shortcomings in the process, then safety in the context of GTK means minimizing the ability to eat our users' data. It means detecting a bunch of issues early at compile time instead of hunting them down because somebody somewhere filed a bug that doesn't tell you much. And also, if the type system can tell you that this blob of data was moved from this function to this other function, and you cannot access it anymore, then it's kind of more powerful to have that inside the compiler instead of having that inside an annotation in a code comment that gets parsed by a Python parser written Flex and Bison, and then gets interpreted by, I don't know, JavaScript. It's, yeah. So, just to make it clear, GTK has 2 ABI boundaries. The first one is outwards, and the second one is inwards. And while we expose one to our users and other libraries and applications, that ABI is supposed to be stable. So we cannot, once we add it, we cannot touch it. The inward ABI is not stable because we want to change it in order to implement the toolkit. But that also means that we cannot use the same tooling that we use to introspect or describe the ABI that faces outwards with the tools that we use for the inward ABI. So we can expose a CABI straight through the Rust code. I don't know if you can read it, sadly. It's kind of a small thing, but this is an example of a crate that is called RDW4, and it exposes CABI that is handwritten because it's not massive. It's similar to how librsvg exposes its own ABI. The C symbols calling from the Rust code. But on the other side of the ABI boundary, it's the internal one, we also need to deal with things like generating Rust code from C symbols. Essentially, we'd be needing a way to generate our own Rust bindings for internal use. And these two would have to be unwritten because we cannot rely on introspection. We are building a dependency of the public GTK API, so we cannot run the introspection parser on that. Luckily for us, the glib Rust bindings have a substantial amount of handwritten code to simplify like wrapping objects and GObjects across the language boundary. But with some work, we can just take it and copy-paste it inside GTK itself. And the real issue with dealing with Rust dependencies is that we cannot really, like, we don't want to copy-paste a ton of code into GTK, but if you think that selling Rust to C developers is hard, try selling the crates ecosystem to, like, Linux distributors for a very core system library like GTK. Because it turns out that Linux distributions are born out of shipping C code to users, and they are not great at doing anything else. I'm sorry about that, distribution developers in the audience, but that's the truth. It took Linux distributions years to cope with C++, and C++ doesn't have a vast ecosystem of modules that are easy to integrate in your code base. Linux distributions are C-oriented platforms, and the people making them are sysadmins. So we are trying to appeal to new developers, but you have to remember that GTK is both an application development library, but also a system-level library. And we cannot flat-pack our old session. Also, like, let's address the fact that cargo is, like, okay. The gentlest way I can put it is that it's an experiment that ran too long, and we're full on into like sunk cost fallacy. As a dependency manager, is like pretty good. As a build system, is ridiculously bad. The only thing that has going for it is the declarative format, which is completely undone by the existence of the build.rs file, because nothing says this is a good build system when it turns out that you have to write native code to build a binary that generates lines of text that the compiler will parse at runtime in order to know what to compile and how. So, no. So, building software ought to be boring, and yet is like the main source of frustration for like software developers. Taking care of portability, dependency, code generation, and doing so reliably is painful. Anything that moves the ownership of that pain from the maintainers of the software to something or someone else is considered an improvement. That's why GNOME moved to Mason, like in record like time. We moved away from autotools, which are still to this day one of the pinnacles of self-inflicted pain in the whole history of computing. And thanks to the work of the GStreamer developers, the Mason developers, and the Mesa developers, we might get better integration with Rust and Mason soon. Ideally, the current thinking is being able to use Rust crates as Mason subprojects. Sadly, Mason subprojects have their own, they've been a constant source of strife for us GTK developers, especially when dealing with CI. And it is abundantly clear that there cannot be free lunches, but it can be a discount. And at the end of the day, adding Rust as a static library for like internal stuff inside GTK is not more complicated than this in Mason. But that is kind of an illusion of functionality. There's a lot more that needs to happen. And the interfaces between the bits are kind of pretty rough at the moment. It will require commitment, not just from GTK developers, but also from build system developers, like packagers and everyone else. Because the main selling point of the GNOME platform is not our scintillating personality, though it's a selling point. or the fact that we have achieved in 25 years and with 25 years, a box of scraps in a cave, what trillion-dollar companies have done. So it's impressive that we've been able to do so. But one of their main selling points, if not the most important one, is that we have a language-neutral platform that people can consume in multiple languages. So we still need to expose a C ABI in order to have other people consume that particular platform in Rust, Python, JavaScript, Perl, Zig. I have no idea what other languages exist today. I'm in a cave, out of touch. So it's not all frictionless, and will require a lot more work, but we still need to be able to do that. So we can also move the consumer of our platforms to better languages, so we can start oxidizing from the root. So writing applications and new libraries in safer high-level languages is a really good thing, and you should not waste your time or anybody else's by porting applications from JavaScript to Vala and from Vala to Python and to Python to Rust, or like vice versa. You should spend more time porting unmaintained applications, making better applications. Port them away from C. Try not to write new applications in C. And then we can also start writing new libraries that those applications can consume. And maybe we can reduce one way to reduce the code side, the C presence in our platform is not just adding Rust to GTK and removing C, but also removing the size of C code that gets shipped every day to our users. And that also includes like making GObject suck less. There's a lot of stuff there. Hypothetically speaking, it might require even an ABI bump or a completely new root of our type system, but who knows? I mean, I've been talking about Rust, but there are other options. C++ is kind of a kitchen sink trash compactor, so maybe we can find something into it without losing our hand in the process. For instance, arfbuzz is written a very strict subset of C++. Arfbuzz is the library we use for doing text shaping. We as GTK, but also web browsers, LibreOffice, basically everyone else. It uses plain old data types in C++, uses a subset of templates, no exceptions, and not even the C++ standard library. So it's very small. VTE, on the other hand, went full C++. It still exposes a GObject like CABI, but it's like exceptions, templates, like metaprogramming, and blah, blah, blah. The main downsides of integrating C++ is that once you do that, you will have a mix, at which point the C will start behaving really badly, because C compiled with C++ is bad. So you will inevitably end up with a C++ project. Carbon is an template placing restriction in C++ with a new syntax. It's a Google experiment, and we all know how they all end up. But Rust was a Mozilla experiment, and also they have a tendency to go up in flames. But Rust is still here. Maybe Carbon will be still here. Of course, I'm kidding. There's Zig, which is interoperable with C to the point that you can use the Zig compiler to compile C and C++. It comes with its own LLVM because, of course, every language on Earth now does. Because, God forbid, you can make GCC useful. It could be interesting in the future. Right now, it's very much underdefined, and who knows what will happen. It's still pretty much in the uncanny valley with the syntax. Apple wrote a Swift to replace Objective-C, another ad hoc language they adopted for their platform. Maybe we can try Vala again, possibly with a proper formal specification. The main limitation of Vala is that in order to fix Vala, you have to fix GObject, and if you fix GObject, you end up breaking stuff. What about starting a new toolkit from scratch and sunsetting GTK? It's just software after all, right? And if there's one thing programmers have in spades, it's hubris. Of course, the cost is not trivial. Ask me how I know. I was the maintainer of Clouder. You still need to interface yourself with a bunch of like low-level C because your operating system is written that way. You have to deal with memory management, windowing system protocols, IPC mechanisms. You need to settle on API, and you need to include a CABI because unless you're Apple, you don't have the pull to do to tell people to only use Rust or a single language. And after that, you have a way you will have to deal with all the features of the desktop system. So accessibility, drag and drop, clipboards, printing, file selection, sandboxing. Then you'll have to ensure that all the application developers, you'll use the new platform. So you have to deal with documentation, tutorials, testing, portability, deployment, distribution. You will have to need to help volunteers, and you will need to convince companies. And most of them are getting paid a lot of money to promise their clients that the platform doesn't change at the drop of a hat. So they will not touch that with a 10-foot barge pole. And there's always the option. Keep working on glib, keep working on GTK, add new features, update new version of C standard, deprecate old API, do a new major release, rinse, repeat. We can keep trying getting new contributors. It's not like most of all we'll see like a state pension anyway, so we're gonna be able to work on GTK forever. It's a threat. But kind of the important message I'd like to convey now is just, it's the time for experiments. Like you can prove me wrong, you can prove me right, you can like take heed of what I found or disregard it completely. You just, yeah, you can say, oh, Emanuele was an asshole. And I mean, yeah, it's fine. I enjoy being proven wrong. But the important thing is people try. It's not a case of just letting it go. So thank you for listening to me rambling. And yeah. So that's my cat. And yeah, sorry, it wasn't non-safe for work, so Elon descended. I'm sorry. So if you have any questions, I think we have still a little bit more time. So ask away. I was super clear. Everyone caught what I said. Wow. Oh no, there's a question.
Not specific to GTK, but if you're writing a new GNOME core library today, how hard would it be to do that in Rust? Like how many features are missing and how many features are there?
So the question is, if we wanted to start a new library, a core library in Rust for GNOME, yeah. To replace the existing stack or an addition?
Or extend, but something that's GObject introspection, we want apps to use it.
Right. So in theory, you don't need much. There is a lot of tooling there already. It's still experimental because right now, all our stuff is either handwritten. So it's written in Rust, for instance, and exposes a C ABI. In theory, there are a couple of interesting experiments there. There's a fork of cbindgen, which generates the GObject stubs for you out of the Rust definitions, and which can be used on top of that to generate the introspection data. In theory, there's also the option of extending, adding new stuff to generate the XML for you or the typelib directly for you. So there are options. The smaller the target, the easier it is to be concise. We are out of time, but if you have questions, I'll be roaming around the hall, so like a ghost of Christmas futures. So ask me.